It looked like, from what I've seen, everybody was either got it or was really close, but there's two answers that kind of came up when we were doing this. So f of x, well, I could put them over here. F of x. Jaden, what did you get?
For my answer?
Yep, for your answer, for the inverse.
I got x plus 3 over x minus 2.
X plus 3 over x minus 2. Now, who got the flip of that? What was the flip of that? Okay. What'd you get back there, Mackenzie?
I got negative x minus 3 over 2 minus x.
All right, those are both right. They're both correct. How can you recognize when, like, you have the exact same answer? We've talked about this a couple of times. You know, somebody gets x plus 3 over x minus 2, but you say, oh, I got something similar, but I don't know if it's the same. Remember how you can check it? Everything is what? Everything is opposite. Every term is opposite. That means you are correct. So that's a negative, that's a negative, that's a negative, that's a positive. So it is. How does this happen? How does one person get one answer, one person gets the other answer? You remember, Zachary?
Is it there's different ways to like turn? I don't know.
Okay, there are different ways, but there's one key thing in solving it that happens that creates that one being all negatives and one being the other. Anybody know? Anybody remember this?
Would it be like which way we move, like which y term to what side?
Yeah, exactly. If you move the y's to the left, you'll get one answer. If you move the y's to the right, you get a separate answer because that changes their signs. It's just basically which way you move the variable you're solving for. Okay, so they're both right. It just depends on which way you moved it. All right, let's go through here real quick. Y equals 2x plus 3 over x minus 1. If I'm looking for the inverse, flip x's and y's. And then I'm going to multiply by y minus 1. And that gives me, I'm going to go ahead and distribute because I'm going to need to. Xy minus x equals 2y plus 3. All right, now here's kind of where it splits, whether you get the one answer or the other. If I move the y's to the left, let me do that. I'm going to subtract 2y. I'm going to subtract 2y. And then I'm also going to add x just to do it all in one step. And I get xy minus 2y equals 3 plus x. But you're typically going to write that as x plus 3. All right, we got xy minus 2y. What do we have to do there to get y by itself? Nick, what do I got to do?
You gotta factor out y.
Okay. Got to factor out a y right here. So y times x minus 2 equals x plus 3. And now that'll give me y, which I'm going to call f inverse of x. Divide by x minus 2. Divide by x minus 2. So there you go. So you get that. All right, so there's your inverse. I did ask for the domain and range. There's a lot of domain and range on this, a lot of it. So make sure that that makes sense to you. Again, Canvas conference tonight. I don't know when, sometime after 9. I'll send out a remind if you want to ask a question or two. But let's see, domain of f, range of f, domain of the inverse, and range of the inverse. All right, domain of f. Alyssa, what do we get?
Negative infinity to 1, union 1 to infinity.
Yep, we got to throw out 1. Domain negative infinity to 1, union 1 to infinity. Whitney, domain of the inverse.
Negative infinity to 2, union 2 to infinity.
Negative infinity to 2. Whoa, what happened? 2 union 2 to infinity. Hannah, how about range of the function?
Negative infinity to 2, union 2 to infinity.
Because the domain of the inverse is the same as the range of the function. Good. And Liz, what's the last thing? What's the range of the inverse?
Negative infinity to 1, union 1 to infinity.
Man, I am feeling a lot of 100% tomorrow. Yeah, a lot of them.
Don't lower your standards just a little
Hey,
bit.
lower my standards.
Just a little.
All right, I'm feeling 100% tomorrow. Maybe, maybe not.
If that's the only quote, yes.
All right.
Send that to provide to the whole class. They'll got those.
All right, let's take a look at it. We're gonna do a couple more here. Anything we do like on these days to review, make sure you keep that with your notes to look over. Okay, because this problem may or may not be elsewhere, but just making sure we hit it. All right, I'll go through it with you here. Just wait to let me get it copied down. All right, if you haven't figured it out, you will see something like this tomorrow. Okay, definitely. All right, f of x plus h minus f of x. So f of x plus h minus f of x all over h. All right, well, the f of x plus h. Okay, remember, you take x plus h and you put it in wherever there's an x in your original function. So it's going to look like this, 3 parentheses, x plus h quantity squared minus 7 parentheses, x plus h plus 4. Okay, so that is f of x plus h minus f of x. Well, the f of x is just your function itself. So minus 3x squared minus 7x plus 4 all over h. That, okay, is your f of x. Make sure that minus, though, when you're separating them, you got parentheses around the f of x because you're going to have to distribute a negative. All right, don't forget, squaring, you've got to square FOIL the x plus h quantity squared. And I'm going to do this over here on the side, just as a final reminder. X plus h times x plus h when you FOIL. X squared plus xh plus xh plus h squared. And what do those two terms in the middle add up to? They add up to 2xh. Okay, that's kind of the key thing that's usually missed. X squared plus 2xh plus h squared. Okay, so we got 3 parentheses, x squared plus 2xh plus h squared. I'm going to go ahead and distribute this negative 7 and get minus 7x minus 7h plus 4. I'm going to go ahead and distribute the negative sign. Everything gets that negative sign. So what did we get? Minus 3x squared plus 7x minus 4 all over h. All right, at this point, distribute your 3 combined like terms. Okay, distribute that 3 combined like terms. And what do I get? Whoops, hold on. I get 3x squared plus 6xh plus 3h squared minus 7x minus 7h plus 4 minus 3x squared plus 7x all over h. All right, a little bit of clue. What's the only thing should be left should contain a what? H. The only thing should be left should contain an h. Everything else without an h should add up to 0. Okay, so that's 3x squared and minus 3x squared. Minus 7x and plus 7x plus 4 minus 4. Okay, now I take those 3. What do I got left? 6xh plus 3h squared minus 7h all over h. And when we do that, since each term in the top has an h, what can I do with that h? I can factor it out, and it should always end up canceling with the h in the bottom. So I got h 6x plus 3h minus 7. Those cancel. And then 6x plus 3h minus 7. You don't need to memorize that formula. I'll give that to you on the test. You do not need to memorize it. Now, I will give you that one. The average rate of change is not on the test. You need to know this one. Okay, so that formula there, the average rate of change. Okay, as x changes from A to B, the average rate of change is f of b minus f of a over b minus a. All right, let's take a look at an example. Okay, find the average rate of change from 2 to 5 for that function, f of x equals 3x squared minus 5x plus 2. Now, key thing, which one's A, which one's B? Okay. As it changes from A to B. So A is 2, B is 5. Okay, so according to the wording of the problem. So we're going to do f of b minus f of a over b minus a. All right, go ahead and see what you come up with. All right, f of 5. Oh, what do you got? What's that? That should be 4. Yeah, that should be 4. Yeah, that should be 4. Because when you FOIL x squared, x plus h squared, you get 2xh. Yeah, then you distribute. Okay, all right, 2x. All right, no, you good. Yep. No, you're right. No, yep, that was you.
How does that help from that?
Calculus.
You said we're gonna use that.
How is this helpful?
Yeah.
Okay, all I can tell you is the derivative of a line is its slope. And this is a way to deal with the slope, because the slope is, think about the slope between 2 points. You take the difference of the y minus over the difference of the x. So these would be 2 y values. And then this would be already taking the difference of the x's. So whatever you added to the, if we add h, then that distance there would be h. So that's that. Basically, all it is a slope formula.
Precursor for derivatives then.
Yes. Ty, what's f of 5?
We got 75.
What? When you were done?
What?
You did, all right, that's 75.
Oh, I see.
And that should be a 5, not a 3. I mean,
52. I got 52.
52?
Yeah,
Okay, that sounds better.
I read the wrong one.
All right, okay, good recovery. Read the wrong one. All right, Liz, what about f of 2? You got 4. I agree. So it's 52 minus 4 over 3, which I get is 48 divided by 3, which is 16. So that should be your answer. Your answer is 16. Average rate of change. Okay. Now let's take a look at that worksheet. I said you didn't have to get it done, which is you didn't. But if for what you got done, let's take a look at your answers. Oh, I'm not there. Hold on. Let's take a look at your answers. I'm going to go through this. I want to get you started on those review problems. Don't go through this. I'm going to go over a couple, but then when you're doing the review, if you have individual questions, I'll come around and see if you have any questions in the review sheet. Okay, that maybe need an explanation. I will explain a couple of these, but if I don't hit everything you have, I'll come around. Make sure you got B here. Zachary, I looked at your answer and I got it for the second one. Why is it C and not D?
It's because it can't be
Because it's in the denominator. Okay, if that was the square root of x minus 8 in the numerator, that would be your answer. But since it's in the denominator, we got to throw the 8 out. So make sure you got that one right. The first, I think, 10 or so questions are multiple choice. Okay, this is one where there's a few more multiple choice than on the others, and the rest you got to go through all the steps. There's about 20 questions. It is 100 points. Don't forget, Stark State. What is 50% of your grade is your test average? Okay, so this counts in that test grade. You already got the chapter 1 test. This will be the chapter 2 test. All right, even, odd, neither. As I've talked about before, you're not good at even, odd, or neither because you haven't done a whole lot of it. Let me do number 4. Let me just make sure I explain that. If you got it, great. If you didn't, maybe this will help. For an odd function, f of negative x is going to equal the opposite of the function, right? So we got to see if that happens. So what does f of negative x look like here? It's going to be negative x over negative x quantity squared plus 2, which is negative x over x squared plus 2. We're okay there? All right, now why is that odd? Okay, why is that odd? Because I can take that negative on top, because there's that single term, and I can actually, you could say factor it out at the top, but I can put it in the front, and then that becomes an x, and that's still x squared plus 2. Now remember, if you distribute that back in, it only goes to the numerator, it only goes to the denominator. It can't go to both. So if I just put it to the numerator, I still have the same thing. Well, what is that right there? Is that our original function? Yeah. So that means that f of negative x is equal to the opposite of f of x, okay? F of negative x. So that means it's odd. First one is even, last one is neither. All right, for 6 and 7, D is for 6, 7 is B. 7 is B. Over here, 8. This one just moves right down 4. Okay, take the whole thing, right 3 down 4. Now you got to watch for 9. All right, now I would tell you, this is what you'll see on the test. You'll see it's called a discrete graph. Okay, you don't know the function name. You cannot plug in values. Okay, it'll just be a graph like this, and then I'll have 2 or 3 of these where you have to move it based upon the function. Okay, so there's not a graph you can plug into. Now for this one, the 2 outside stretches it vertically. The negative, since it's outside of it's not with the x, it flips it over the x-axis. So this should be that answer. Now, I'll be able to tell what points, be clear on the points. You don't need to label them. Okay, you should be able just to put them down and connect it, and it should be pretty obvious. But just be careful when you're doing it. All right, now once you're done, flip it over. What's the next one? 10? All right, 10. the tube inside with the X is the horizontal compression. Okay, so it shrinks it horizontally. So basically cuts it in half. So this was at 10, -10, it's gonna be at -5. And then it's moved up 6. This is at -2, it's now at -1. This is at 2, it's now at 1, and this is at 10, it's now at 5. And then everything shift up. So that's how you do that horizontal compression. Doesn't change the Y coordinate. Just shrinks it horizontally. Okay. 11. All right, 11 and 12. Still a little bit like this is some people still have a couple issues here. Make sure this starts at 0. Okay, it says X is greater than 0. You cannot start it at 1. You have to start it at 0, but you put a open circle. All right, now take a look at that one and take a look at what you got. Fix it if you need to. I'm also going to ask you the domain and range. It's not on this sheet, but go ahead right now so you can label the domain and range. Label the domain and range. That's a nice view. Very nice. All right, based on this, your domain is all real numbers. Okay, as I plug in numbers, I get an answer everywhere, even at 0, because when I plug in 0, I get the answer -3. Doesn't matter that this open circle, I have at least one closed circle there. And I go to the right, I have answers. Now, range-wise, those are your Y values. This horizontal line, okay, if it's just a constant, remember, it's a horizontal line. That hits just at -3. Okay, so it's just singleton there. Union, that other piece goes from -1 to infinity. Okay, that other one goes from -1 to infinity. Okay. All right, that's 11. 12, you got 3 pieces there. All right, take a look at this and see if it matches what you have. One thing you got to be careful, what's the scale on the Y-axis though? Did you notice that it is actually, goes up by 2s. Okay, so if it might not look exactly the same.
I'm gonna ask myself as
Okay.
well. I realized that we did that wrong.
Oh, okay.
I'll take a tally for that.
Oh, you get one? Or we're probably not even close to even yet.
Oh.
I mean, I'm still way ahead.
Are you sure you're ahead? Because he's a lot more ahead than both of us.
Oh, yeah. Oh, wait, what are we saying ahead? I'm saying I have more time.
Yeah.
He's like
Oh, yeah.
40 plus ahead of us.
40 plus ahead?
Yeah.
So tallies are mistakes, right?
Yes.
Okay, just making sure. All right, we did it there. All right, you get it?
I had it the first time I had it like this, just like a dot right here.
They get connected.
Yeah, but I think it's because of the Y-axis.
Hey, and it's hard, it's sometimes hard, so the booth should not be connected. Okay, do not, oops, sorry. There's always the urge to make it one graph, but they should not be connected, okay, at any point. And I'll give you time, I mean, obviously you can finish that, but make sure you understand how to do this one. You can do an XY chart. So like for the first one, y equals 3x plus 2, or f of x. All right, that's only for x. That's only for x is less than -2. Again, I'm gonna keep stressing, but you have to plug in what number? You gotta plug in -2, even though it doesn't equal it, but that's your starting point. When I do plug in -2, I get -6 plus 2 is -4. That's why you got an open circle right there. Okay, it starts right there. Go to the left. Double check, because every now and then I get people that go make things go backwards, and I can't figure out why or how to explain it differently. But make sure you go, since it says less than -2, make sure I go -3, -4, which gives me -7, -10. -3, -7 would be here. -4, -10 is down there. F of x equals x. There's just a tendency to want to make that harder than it is because you're like, that's too easy. Whatever you plug in is what you get back. You plug in -2, you get back -2. You plug in 1, -1, you get back -1. 0, 0, 1, 1, 2, 2, and then 3, 3. And it's really that identity function. Okay, it's really that identity function. It has a definite starting point, a definite ending point. But I stress, they should not, for this example, be connected. There could be cases where they do overlap, but not this one. Make sure this domain makes sense, -infinity to infinity. Hits everything. Make sure this range makes sense because I got a break in the y values, so I got to have 1, 2, 3 different pieces. -infinity up to -4, union, the -2 to 3, then union 5 to infinity. All right. I'll come back to this later if needed. Let's hit 13 and 14. 13 is a composition function. You're going to end up with 49x squared plus 56x plus 14. Do not worry about factoring or anything else. Just leave that. Okay, just leave that. And now 14 can be confusing on that one. What's f of x for 14? What do we got? Carter, what's f of x for 14?
3 over x plus 4.
And what is g of x, Carter?
12 over x.
12 over x. So I want to figure out what f of g of x is, and I want its domain. Madison, so which function do I plug into first? If I take a number, I want to find like f of g of 2. Which number do I have? Which function do I have to plug it into first?
I took the f of x and plugged the x into it.
Okay, now you're saying it right. So we got to plug into, let me do this. You would plug 2 into which function? G function. What aren't we allowed to plug into the G function? Anybody? 0. So that means right from this get-go, x cannot equal 0. That's going to come back when I do the domain later. So you're right. We want to take the g of x function. So it's going to 3 divided by 12 over x plus 4. Got to simplify that. Okay, you got to simplify that. Now, how's that simplify? Get a common denominator with this 4. And make that 4x over x. Because I got to make an x in the denominator, I got to put an x in the numerator. That's going to be 3 over 12 plus 4x over x. All right, when you invert and multiply, 3 times x over 12 plus 4x. And when I'm done, that's what it should look like. Okay, 3x over 12 plus 4x. All right, now I want you to think domain. We already said x can't equal what? X can't equal 0. What else can't x equal? 12 plus 4x is not allowed to equal 0. Okay, so that means 4x cannot equal -12 when I move that over. X cannot equal -3. So you got 2 pieces you got to take into account. You can't equal -3. You can't equal 0. So here's what I got for the domain. -infinity to -3. Union, -3 to 0. Union, 0 to infinity. Okay. All right, I wanted you to give a little bit of time, at least. These are test review problems. I just showed you where the answer key is. Definitely take a look at these. Hey, as you're going over, I'll be on, like I said, a conference tonight. I'll have to send out a reminder as to when, sometime after 9 more than likely.